secure, and more. If I can present half as good as I can make up funny titles, I got this. Thank you, ARC, for making your default slide set color match our logo. I really appreciate that. And do we have any water wastewater folks here? Not a single one? Oh, thank God. I can tell you anything and you won't know. This is awesome. So, my name's Jason. I'm the Process Automation Manager, Lynchburg Wastewater. We're a critical infrastructure as defined by Department of Homeland Security. We're one of the 16. We operate 24/7. We permitted to treat 22 million gallons a day, but when we have rain events, we'll sometimes hit peak flows of up to 70 million gallons, and I'll talk about that in a moment. We discharge to the James River, which is part of the Chesapeake Bay watershed, so water quality is a very big deal. If anybody was here yesterday and heard the guy from Department of Homeland talk about they offer a free security and cybersecurity assessment, and he made the comment, he said, hey, 43% of the people that have taken us up on this have come from the water sector. And I sat in the back and I'm like, yeah, because it's free. So as an industry, we tend to lag behind in automation. We don't really have a lot of money. We're publicly funded. We do get ratepayer money. We're kind of city councils, municipalities. So automation's a big deal for us, and where and how we spend that money and justify it's a big deal. We truly live the adage, do more with less. So let's talk about arguing for a modernization project. Everybody here understands automation, I hope, right? One of the big things for a wastewater plant, we're what's called a secondary plant. I won't get too technical with you. There are tertiary plants. They do further treatment. But our final process is to chlorinate the water to kill any pathogens that are in there. And then we have to dechlorinate the water so that we don't kill fish and marine life. So that dechlorination is a critical process for us. If we lose that dechlorination, within 15 minutes, we could be in a state of violation. At best, we'll get a notice of violation. Anytime we lose dechlorination, we get that NOV notice. Just kind of tells you you had a violation. Next step up, we're going to have fines. Worst case scenario is what's a fish kill. That's what you don't want. That's a PR nightmare. You just don't want to do it. So it's a critical process for us. We had a legacy system. We're using flow meter. We had a flow meter connected directly to the pumps. As flow went up, the pump would increase speed. But our operators would have to go out and do hourly checks to make sure it was working, because that was really it. There was no true automation. And because of that distrust of the system and those hourly checks, we had chemical waste. There's no limit on how much bisulfite you put into the water to counteract chlorine, so you can over bisulfite. So our operators would tend to crank up the dose a little bit to give themselves a cushion. So obviously, what can you get with automation? Well, you can get monitored pumps. You can have a redundant system. We can have pumps come on automatically if one fails. Our operators can be notified of abnormal situations. A big savings for us would be chemical, because they can see that the system works, it's online, so they don't have to feel that cushion to crank it up. Automation minimized our largest risks, and it didn't kill fish. So criteria for choosing an automation platform. What does the converged IT, OT, ET give us? First and foremost, I'm a wastewater plant. It's wastewater. I don't have to tell you what it is. It's a nasty environment. The stuff has to be robust. It has to survive. I really, really respect the pioneers that are doing really cool stuff out there, like, running I/O with a Raspberry Pi. But I can't install that in my plant. I need something that's going to survive. I need that ruggedness that I'm used to in the OT world. It has to be able to survive extreme conditions. Obviously, we need the IT level cybersecurity. That was actually a very critical thing for us when we started looking at this. If we're going to spend our money, why would we not invest in something that increases our cybersecurity posture and keeps IT happy with the things we're adding to their network? And then finally, the engineering technology, that ET side of things. Paula talked about a digital twin. I have a kind of my take on it. But what do we need to do for the modern engineers? Y'all have heard the stories. Automation's having a harder time finding workers. How do you get people to come into our system, to our our workflow, where are these engineers coming from? I'm a ladder guy. I'm older than I look. I know ladder logic. I know it very well. I can read it. That's how I learned to program. Most of my friends, my millennial friend engineers coming in, they came from a computer science background. So structured text is actually more natural to them. They understand computer programming. They do stuff in Python all the time. They know that, and they're used to working with modern tools. So the modern OT engineer needs modern IT engineering platforms. I won't get much about the cybersecurity because there's a whole other track on it. I will leave you a very good cybersecurity tip that my daughter told me. Don't use beef stew for your password. It's just not strong enough. Thank you. She didn't think I'd actually say it. So let's talk about the controller that we chose and we went with for this project. I'm going to discuss our take on a plant twin simulator, and I'm going to try and not laser people in the face. All right, right here, if anybody's familiar with kind of how PLCs look and how they're set up, we have our controller, we have our I/O chain, we have our projects. I won't get into a lot of detail on it, but that is our actual physical hardware setup. Right here, and I did highlight it before I took the screenshot, that is a complete digital twin of the setup. It's a little bit harder to see, but analog, discrete, bisulfite CSO, bisulfite CSO. It's a software copy. What that gave us, that's the modern engineering technology I'm talking about. Change management, testing, validation, real-time production data being used to feed this thing. So we have hardware. We're able to run that hardware in production, but we have a software simulator reading those real-world inputs. I want to make a code change. I can go online, do that in the software simulator, see what happens to fake outputs using my real-world inputs. It's not a true process simulation. It doesn't understand the nuances of the plant, but it does give me very simplistic ability to do code testing and change management before deploying it to production. This is a tool that the IT world has used for years, or should, before they apply patches to your live environment. They should have a test environment. VMware, you can spin up a test machine and run patch. This gives you that in the ET world. Little things, the color coding on the structured text, the commenting, the inline autocorrect, these are things that are used to in IT world. This is the stuff that's in a normal integrated development environment. If you code in Python, these are the tools that you're used to using. So again, getting those modern engineers to come in and understand PLC coding, this looks like Python to them. They kind of understand that. Scan time speed analytics, this development environment gives us and I'm not saying it's the only one out there, but it gives us the ability to read that PLC code and do traces on it at the scan time of the processor. We can stop and step through one step at a time in the code. We're able to debug faster. We're able to optimize our code. We can see things like contact bounce because we're running at scan time and look for ways to say we need to induce a little bit of delay here, or this is why this input's not firing. This isn't marketing, but Codesys, the system we chose is based on Codesys. Codesys is an open, anybody can buy it, use it, and install it run their automation. Globally, they're huge. In the US, not so much. But a benefit of Codesys, it's an established platform, it's huge worldwide, and it has a vast library called a store, but they have a vast library of pre-built things. Anybody from IT in here, think of Python. If you want to import, if you need to make a delay in your code, import time, sleep 5. Your code will now stop for 5 seconds and then execute. It's that simple. You didn't have to write anything to read a clock. You just simply said import time. Same concept. If I need a totalizer, I could build a totalizer from scratch in structured text, or I could say import the OSCAT standard library totalizer and pull that in. So very beneficial for us. That's the and more. Now I want to tell you about a second project, and this was the real benefit of having this type of converged device. In the middle of the project, doing the upgrade for the bisulfite pumps for our dechlorination, we had a mandate come out to do something with CSO. What is CSO? Combined sewer overflow. Old wastewater systems, mostly on the East Coast. It starts to go away on the West. Your sewer system runs, oh, sorry, that actually is the skyline of Lynchburg, just saying, props to my marketing department. Sewer runs down through to the plant. You get a heavy rain event. We recently had one on my drive down here. They got hit. I was going to Florida. They hate me right now. All that stormwater comes into the system. It overflows. It surcharges the pipes. They can't handle that flow. So you get a spill out to the river. And she did a great job of showing it's mixture. It's not 100% sewage, but there's still a spill. You are getting that stuff out there. There's a big push in our industry to get rid of this and do something about it because that's still affecting the Chesapeake Bay. We were told to make a public notification system. The cost to completely separate, the ideal situation is separate the two systems, stormwater over here, wastewater over here. That's $300 million in Lynchburg. We're never going to be able to do it. But to upgrade the plant to receive all that flow, $30 million. That we could do. So that's a project we're in the middle of. Prior to completing that project, we have to build a notification system to tell the public we're having an overflow, an event occurred. You need to just be aware. You may not want to swim in the river right now. I don't know, but just be aware. It was a challenge. It came out and we were told we had to do it, and we had to do it very fast, short amount of time. Again, do more with less. That's our adage. So what's the I don't want to use the word cheap. It has a negative connotation, but what's the least expensive way we can do this? We need to leverage stuff we already have. We need to reuse existing systems, and we need a prototype to see if it'll work. That modern converged controller we were talking about. Sat down and said, you know what? This thing has an I/O scanner on it. Could we scan this I/O? In 10 minutes, we were up and running. We had it scanning some of the remote I/O, the data radios that we already used, the existing system we were leveraging. Said, okay, we can read it. Well, I know we can program logic in a PLC. That's what I do. Not a problem. So once we had that 10-minute proof of concept, said, okay, we can keep using our existing I/O. We can now use this existing controller. I think we can make this work. We started doing that development in conjunction with the other project while that was still going. That IDE simulator that we talked about, that virtual digital twin, for us, I know everyone's different, we normally have our panels built locally from a local panel builder because it's an inexpensive cost for us. We ship them to our integrator who does the programming because he wants to have that hardware physical. Nobody wants to give something to their customer that they don't know for sure it works. So we ship him the panels, he'll hook up lights and switches, do his tests, do his code, ship it back, our electricians install it, he shows up, does the startup. That's a normal workflow for us. This time, he was able to do the entire thing virtually. He had the confidence that this code is going to work because he had a simulator that functions just like that PLC. So we had the panels built, we had the electricians install and wire. He showed up to do startup. Everything pretty much worked. Very fast, very efficient, big savings for us, big savings in cost, no shipping, big savings in time. Zero additional hardware cost because we already had those scanners built in. So, again, modern converged devices. Why are you restricting your users from having all the tools you can pack in there, right? Why are you charging them for structured text? We leverage the city's existing alert system. The city already has a public notification system. We were able to hook into that and use that for the CSOs. So anybody who's interested, look up my website, our city's website, sign up for it. I know everybody wants more emails and texts in the middle of the night, and you'll be notified that you had a CSO event. And just for me to brag, we were the first ones in Virginia to deploy a real-time sensor-based public notification system. One of the other major cities built a system that, and I'm not knocking that, it works great, but they use prediction on rain. So they say, yeah, we had X number of inches of rain for so long, there was most likely an overflow. Ours, we're actually saying, yep, there's an overflow right now. And we do a 30-hour all clear. After 30 hours after the event stopped, we say it's been 30 hours. Most likely the river has cleaned itself out based on all the flow, if anything did get in there. So what are the benefits of a converged IT, OT, ET piece of technology? Why would you, at the controller level, want this? Coding environment. engineering best practice workflow. The next generation of engineers are going to demand this type of stuff. They're not going to want to work with legacy systems. They're not going to stay in our trade. Our industry will suffer. This makes it faster. This makes it cheaper. The plant twin change management, I mean, come on, IT has been using this forever. Why don't we have it in the operations technology field? Why aren't we using these type of things? What Paula talked about, we're not to that level yet, but my God, that would be amazing if I could have predictive analysis at my plant. Of course, we had enhanced cybersecurity posture. I could talk forever about how much stuff is built into that particular system, but catch me outside of here and we can discuss it. And then that scan time analysis for troubleshooting, that actually was really beneficial for us. We really liked it. Everybody here really cares about the big numbers. We saved 25%, $30,000 based on projects of that size that we had done previous. So to us, that's a huge amount of money for something that's in our range. Both projects done concurrently and on time and under budget. Thank you.